the bottom?
No, you leave them just like that because they're both
Just
different. So,
because one's plus and one's minus, you can't put them together.
Yeah, but we don't care that much.
so here's the concept that I need you to know how to do. Step one.
Okay.
Yeah. Because at this point, 95% of the time when you're doing these types of problems, you'd be plugging in a value for x. Or, you know, so you're trying to find the slope at that point or something like that. And you don't want to clean it too much to get that wrong, you know? So the derivative is what I'm looking that you know how to do.
Okay.
Is everybody okay with that?
I can do the derivatives. The cleaning up that I'm always.
Okay. So in the same breath, let's try
Can we just do like
number one.
thing?
So we have x squared plus 1 times x plus 1 squared, right? Did I write it right?
Yeah.
Okay, so how do we do this? We're going to do the derivative of the first, which is what?
2
2.
x.
2x, sure.
Good. Derivative of the first times the second plus the first times the derivative of the second. What rule?
Chain rule.
Good.
2 times x plus
2 times x plus 1 to the first times x, or 1, yeah.
So you do the chain rule when there's an X on it, right?
Right.
Okay.
Now that would be done. If you want the challenge of cleaning it up, I could show you.
Yeah.
Which one do they have in common? X plus 1.
X plus 1.
And what's smallest?
X plus 1 to the first.
Okay, so if I factored out x plus 1 to the first,
Yep.
I'd be left with a 2x,
Yes.
one of these.
Yes.
Times x plus
Yes.
Okay,
Plus.
I'd have x squared plus 1.
Times
That's still
2.
there.
Then
That's
that one goes
gone.
away.
Times 1 times 1.
Okay.
If I clean it up a little bit, I have, what's that, 2x squared plus 2 plus...
2x.
2x.
Yeah.
2x.
Thank you. Plus 2x squared plus 2. Still the x plus 1's going for a ride.
And you can still factor something out in the inside.
Yeah, because if we, what, 4x squared
Yep. Plus 4x. Or 4.
plus 2x plus
Yeah.
2.
Yeah.
Wait, how did it?
You take back the...
Might
But
not be able to, you
yeah.
could probably pull out 2.
Yeah, you could pull out a 2 from the inside.
I don't know how you would factor it.
I don't think it's
I don't know if it's
factorable.
factorable.
I don't think it is.
Miss K?
Yeah.
So when you pull out a 2 from the front, you don't pull out a 2 for
I'd pull
the...
a 2 right here
Yeah.
and write x plus 1 and then left with 2x squared plus x plus 1.
So that 2 does have to come out to the x plus 1.
Yeah, you could do that. You could pull it out.
Leave it like that?
I'd leave it like that.
Distribute the x plus 1?
No.
No?
So you don't even need to pull out that 2.
So anything after derivative we don't have to do. Yeah. I can.
Yes.
Do you have to
Yeah.
pull out
We
like
only
the X
have
plus
to
1 to do it, or can you just simplify it without?
You could boil it and simplify it as well.
But is Cambridge going
They're not. They're going to say find when x is 1.
And then you plug in
So
1.
I would just plug in 1 here and here and here and here and then clean it up. I wouldn't do the algebra of it. I would find, like, they're going to find what's the gradient when x is 1.
Copy and paste that.
I just plug in the 1 for everywhere I see an x, and that would be the gradient. No different than me plugging the 1 here. So
But that's just extra
mistakes could be made,
Mhm.
not so much. In AP
Lots of
calculus,
mistakes.
they would much prefer you see that as well.
Miss K? Yeah. So could you do like on the fourth quadrant,
Yeah.
number 4,
Yeah?
x to the 7/5 minus x to the 8/5 over the 5th root of...
So the 7/5 and 8/5 scare you.
Yes. And
Mhm.
the 5 root on the bottom.
Once again,
What would that graph look like?
not pretty.
Not pretty. I don't even know. I can't even imagine what it would look like.
And it's also going to be an asymptote too, because you've got something in the denominator.
Yeah.
Do you guys agree it's x to the 1/5?
Yes.
Yeah.
Okay.
Where
So,
are we? We're in the fourth
we're in the
quadrant.
fourth quadrant, number 4.
So it's just the quotient.
Really, before I would go that way, I would notice
They all fit.
They all have a base of x. And I have one item as my denominator.
Oh.
So I would say, look, I could rewrite this.
X to the
Now
seven.
we're rewriting things before we do it.
Oh, okay.
Sometimes it's easier to do the algebra first,
It really is.
right? So when I divide, you see what I did? I didn't
Yes.
change anything, I just separated it into two fractions. When I divide same base, I do what with my exponents?
Subtract.
Subtract them. So 7/5 minus 1/5 is 6/5. So I have x to the 6/5 minus x to the...
Seven.
Now, I can use the power rule to do this problem.
Mm-hmm.
Its derivative is not bad. What would the derivative be? Well, 6/5 comes to the front. Write the x.
To the negative
Subtract 5 over 5. So 1/5.
1/5.
Minus 7/5 comes to the front. Write the x. Subtract 5 over 5.
2/5.
2/5. And I'm done.
Wow.
Yes.
Are there any other hard ones like the ln's and the sines and cosines and the e to the
For
x?
now, we'll work on them together.
Even the sines and cosines
No,
one?
sines and cosines I think you should do.
Because you showed the trigonometric functions and how to do them.
Like, let's do in the second quadrant, number 4. Oh, and number 1. I like number 1.
But skip number 5 because that has logs.
For now.
And, yeah.
We'll go over it.
We're doing number 4, you said?
I think I'm going to do number 1 on the second quadrant and number 4.
Okay.
I have time? What time is the bell ring?
Oh.
49 or
Oh,
29.
now?
You got 3 minutes. Like 3 minutes.
I got 3 minutes. So y equals, instead of x to the 5th root, I'm going to put x to the 5th root, if that makes sense. Times cotan, I just wrote it like that instead of with a square root thing.
I didn't understand.
Which one is this?
The first one in the second quadrant.
Instead of x
So
to
they're
the
the wrong box.
fifth root, she's gonna do x to the 1/5.
Yeah, I just heard x to the fifth.
Yeah. Okay, so what do I have to use?
You have to use the
Product rule?
product.
So the derivative of the first minus 5/5, so minus 4/5. Is everybody okay with that derivative?
Yep.
Times the second
Mm-hmm.
plus the first. What's the derivative of cotangent?
Negative cosine.
Negative cosecant squared, right? Am I right?
The square, yeah.
So, but this is actually, right, this is actually a chain rule in disguise. Don't. So, the chain rule says take the derivative of the outside. So what's the derivative of cotan? You said negative cosecant squared.
Yes.
So I'm going to write negative cosecant squared and keep the inside alone. And then what's the derivative of the inside? What's the derivative of 2x?
2.
There's your answer.
And you leave it like that? You said you want to do number 4?
Give me a minute. Yeah.
What is that?
So,
Is that code?
right, so derivative of this, you guys see,
Yeah.
times this. Now this one is where this comes down. Now the derivative of cotan alone is negative cosecant squared. But it has a 2x in there.
Okay.
So then I have to take the derivative of the 2x,
Oh.
which is 2.
Oh, okay.
Yeah, okay.
We're feeling like full.
That minus I probably would bring right here, just so I don't think it's not a subtraction. And then you'd leave it just like that. Okay, so my challenge to you is go home and try as many as you can. Tomorrow we'll come back and work on them.
Yeah.
Okay?
Where's the test?